I just wanted to do a problem that Olivia asked me about after class, a homework question that seems kind of hard, and I messed up my answer, or I couldn't figure it out when she asked me, but I know how to do it now, so I thought I would just do a video and show everybody how to do it at the same time. So the question is this, a man is walking away from a streetlight, away from a streetlight, and it is a 15-foot tall streetlight. This is a related rates question, by the way. So here is the street light. Here is the bulb. Okay, and so the man is, you're told that he's 6 feet tall. And so let me draw a picture of him. So here is the man, and here is his hat. And so he is 6 feet tall, and let's look at what's going on here with the light. Okay. And what is the question? So he is moving this way at 7 feet per second. All right. So we know the rate at which he's moving. And the question is how he's walking right away from the streetlight, and how fast is the tip of his shadow lengthening? Okay, so here's the tip of his shadow. And you can imagine that as he walks away, if you can just see it in your head, like I kind of can, it's a hard thing to visualize. But as he walks away at 7 feet per second, you know his shadow is going to be getting really long, really fast. And so we're going to find out, the question I guess asks, how fast is the tip of his shadow lengthening when he is 32 feet or something like that from the streetlight. And I'm sorry that I don't know this number. I think it's 32. So maybe it's just as well that I change it, because I think everybody has the same question for this one. From the light. Okay. And I thought about this I tried to do it several times, and then I finally figured out how to do it in the middle of my second class. So the trick, let me draw some more stuff here. Alright, so this is 15 feet. I hope you can see that. And the trick to doing this question is to draw this, okay? Alright, and maybe just so everything looks nice, I'll make this line nice and straight too. Here's another side of this triangle here. Alright, so we have two triangles, a small triangle and a big triangle. And I'm going to call this X, and I will call this bottom side Y. Alright, one thing you know is that this part that I'm shading here in blue, well, the man is 6 feet tall, and so if there's 15 feet here and he's 6 feet tall, then there's going to be 9 feet left for this side of the triangle. Alright, so you know whenever you're doing a related rates question, what you have to do at some point is come up with an equation that relates everything. Alright, and so you're going to do that in this case using similar triangles. So let me just label some parts of these triangles. Okay, so let me call this A, I'll call this B, I'll call this C. You guys are probably just vomiting all over your computers right now with this color. And I'll call this one E, okay? And I'm going to say that triangle ABC is similar to triangle CDE. Okay. So I don't want to bang it over your heads, but you know, what am I saying? It's just saying this big triangle is similar to the little triangle. And that's because they have three angles that are the same. So you know, if two triangles have all three angles the same, then one of them is just like a bigger version of the other one, right? So that's what similarity means. And why are they similar? It's because, well, they both have a right angle here, right, for this part. And they have this angle in common, so that must be the same for both triangles. So the only thing left to show is that this angle is the same as this angle. And the reason that that's true is because both of these lines are horizontal. And so of course they're going to hit this line at the same angle because they're parallel. So that gives you similar triangles, and what good is it? So the way similar triangles are normally used is you can say something like this. You can say the relationship between x and 9. Okay, so let's find those in the diagram. So here's x and here's 9. The relationship between x and 9 is the same as the relationship between y and 15, right? Those just play the same role. All right, and now this is your equation. And you take d dt of both sides. And remember that primes pop out because neither one of these symbols x or y is the variable t. So it's really easy equation. You just get x prime over 9 is equal to y prime over 15, and actually I guess 32 turns out not to matter for this problem. So okay, so let's think about what it is we're seeking. We're seeking y prime, right? Because y prime is going to be the rate at which y is increasing, and that is the length of the shadow, and so that's exactly what we want to know. And so we should solve for y prime because that's the quantity that's being sought here. So that is 15 times x prime over 9. And now we'll be done as soon as we can find x prime. And what do you think that is? Well, that is just, you can see it's the rate at which the man's head is moving forward, which is just the rate at which his whole body is moving forward. And so that is 7 feet per second. They tell us that as an assumption. Okay, great. So now we know everything. So the answer, the rate at which the shadow is advancing, is 15 times 7 over 9. And if you cancel the 3 between the 15 and the 9, then what you get is 35 over 3. Or is that right? Yeah. Okay, 35 over 3, and that is the answer. So sorry, Olivia, for not being able to do that after class, but it was a hard question now, so everybody got to see the answer.